Okay, evaluate the indefinite integral, and here we have the integral of z squared divided by z cubed plus 1 times dz. So the first thing we're going to do is we're going to let u equal the denominator of this integral, and that denominator is z cubed plus 1. Okay, now we're going to take the derivative of both sides. So we have du, which is equal to the derivative of z cubed, which is 3z squared, and that's dz, and then derivative of 1 is 0. So if you look here in this problem, we have z squared times dz, and we don't have a 3 up there. So we're going to have to bring the 3 to the other side of the equation, and in doing so, we're going to divide both sides by 3. And so therefore we end up getting 1/3 du, which is equal to z squared dz. So let's take a look at step number 4. We're going to go ahead and rewrite this question, and we have 1 over z cubed plus 1 times, I'm just going to write the z squared being multiplied by dz because that means the same thing. We're just using the commutative property of multiplication, and then it allows us to see what we need to substitute. So let's go ahead and do the substitution. So we have 1 over, well, we know that z cubed plus 1 is u, and then we're going to multiply it by z squared dz, which is 1/3 du. So that's 1/3 du. And so therefore, let's factor out the 1/3, which is the constant, times the integral 1 over u du. Okay. Now at this point, we need to recognize that this is a derivative. In this case, the antiderivative of 1 over u is going to be the natural log of the absolute value of u. So you want to make sure that you have those particular antiderivatives known. So this is going to be 1/3 times the natural log of the absolute value of u plus c. Now what did we recognize u to be at the beginning, which is z cubed plus 1? So this is going to equal 1/3 times the natural log of the absolute value of z cubed plus 1 plus c, and there is our result.